Whenever we hear the word circuit, something like this or this comes into our mind, but all of these are printed circuit boards. So before finalizing these designs, the designers need to create a prototype of the circuit using breadboards to check the performance of the circuit. So hello everyone, I am Utshav Niyogi from Department of Physics, Netaji Subhash Mohabidyalayah. Today I will introduce you to breadboard and its fundamentals. So a breadboard looks like this. It can be of several shapes or sizes. You can also get a small breadboard, you can get a big one. It completely depends upon the size of the circuit that you want to prototype. Alright, so we will talk about this breadboard. So you can see there are several holes inside the breadboard. So these holes are basically used to insert any kind of electronic components inside it. So you can insert an IC inside the breadboard using these holes, just like this. Just like this. Okay, you can insert an LED inside a breadboard, just like this. You can insert a transistor inside the breadboard. You can insert a capacitor inside the breadboard. So in this way you can insert anything inside the breadboard and create a prototype of your circuit. Alright, you can also get some jumper wires and insert it into the breadboard and also connect your components together. Alright, in this way you can create connection among your components that are present in the breadboard. Alright, so now it is our turn to see the structure, the connection of the breadboard. So the connection of the breadboard looks like this. Let's take our breadboard here and understand the connection. So you can see there are basically 4 segments in the breadboard. This one is the first segment, this one is the second one, this one is the third segment, and this is the fourth segment. So there are basically 4 segments in a breadboard. So first see the connection of these 2 segments. Alright, so all the holes available in this segment and this segment are connected vertically to each other. That is, this hole is internally connected to all the holes below it with the help of a metal strip. Alright, so that means if you give this point a signal, this signal will be available in all these 4 holes. Alright, same for any hole in this segment. If you give a signal or a potential to this point, this will be available at any hole in this column. Alright, you give a signal to this hole, this will be available to any of these holes of that column. Alright, same here, if you give any signal at any of the hole, this will be available at the column where the hole is situated. Alright, but see, there is a break between these 2 segments. That signifies that if you give a signal to this hole, you can get it in this column only. You give a signal to this hole, you get it up to this column only. Alright, you are not getting the signal here. Alright, because there is a break, we can see. So we have seen that the holes in this segment and this segment are connected vertically. So let's see how the holes are connected in this and that segment. Alright, so in this segment the holes are connected horizontally. That is, if you give a signal to this pin, you are getting this along all the holes in horizontal direction. Alright, but there is a small catch that you are not getting the signal everywhere in the horizontal direction. There is also a break here. See, here is also a break. So that is, if you give a signal here, you are getting this up to this hole. You are getting this up to this hole and every hole in between these 2 holes. Alright, and again if you give a signal to this hole, you are getting this up to every hole in this horizontal line. Same for this. Alright, and the connection in the lower portion of the segment is also same. If you give a signal to this hole, you are getting this up to this hole. You give a signal to this hole, you are getting the same signal up to every hole in this line. Same for the right segment also. So we have seen how the holes of a breadboard are connected internally. So now let's see the inside structure of a breadboard. So a breadboard basically looks like this. Okay. So here is our breadboard. So I have said that all the holes are connected internally using metal strips. So you can see in this image there are metal strips connecting all the holes vertically, and these metal strips basically connects these holes horizontally. All right, so that's how the holes inside a breadboard are connected. We can also check these things with the help of a multimeter. So we will set the multimeter in continuity mode first. The multimeter is in continuity mode, and we have our breadboard here. We have connected our multimeter to two male jumper wires so that we can directly insert our probes into the breadboard. All right. So see, whenever there is a short circuit between these two terminals, the multimeter beeps. All right. See, it is creating a beep sound. So in this way, we can see where there is a short circuit in the breadboard. All right. If the holes are connected together, there will be a beep sound. This is simple. So let's check the continuity. See, I have given it, I have inserted it to the first hole and checking the continuity here. See. So in this column, at every hole, the multimeter is showing continuity. That is in column 1, every hole is connected internally. But in the whole setup, you can see nowhere else it is beeping out. All right. There is no beep sound at any other place. That is, the hole is not connected internally to any other hole except the holes present in this column. Very simple. So let's check here. See, I am inserting it here. There is no continuity. Inserting it here. There is also no continuity. Inserting it here. There is also no continuity. But whenever I insert the probe into any of the hole present in this column, it starts beeping. That is, the holes are connecting internally. But see, I have said that there is a break. So in the upper holes, there will be no continuity. So see, there is no beep. There should be no beep. All right. So same goes for this. If I connect it here and check for continuity in this hole, it should beep. But there is no beep. There is also no beep, as I have mentioned that there is a break. All right. Same goes for the upper segment. See, there is continuity, but there isn't continuity. So we have seen that we can also see the internal connections of a breadboard with the help of a multimeter. Now you will create a very simple circuit with the help of a breadboard to understand its basics more precisely. Okay, we will just create a LED circuit with the help of the breadboard. So for creating the circuit, we will need an LED, a resistance, a voltage source, and a push button. All right, we have all the things that are necessary to create the circuit. So our goal is to create a circuit in which whenever we press the push button, the LED glows up. Okay, so first let me insert the LED into the breadboard. So I have inserted the LED into the breadboard. All right, now I am giving the ground connection to the negative terminal of the LED. See, this is the ground connection. All right, and then I have to add a series resistance with the LED so that it don't get burned up. All right, then I have to add the push button in series with the LED. That's how I add the push button. All right, then we will connect our positive terminal to the remaining end of the push button. Now the LED should glow up whenever we push the push button. So let's see whether our circuit is working or not. See, our circuit is working very well. Whenever I am pushing the push button, the LED is glowing up. So that's how you can very simply create a basic circuit using a breadboard. So that was for today. Thanks for watching.